At a welcome program, 4 student helpers will each be paired with 1 different new student. The new students are chosen from a group of 6. The helpers are Anna, Ben, Kara, and Dan. The new students are Xavier, Yara, Zane, May, Noor, and Owen. However, Anna cannot be paired with Xavier because Xavier needs language support from a different helper. How many different buddy pairings are possible? Pause the video. Try it before I show the trick. Hint: count all ordered pairings first, then subtract the bad one. Here's the trick. 2 steps. Step A: count all the ordered pairings, with no restrictions. Helper 1, Anna, has 6 choices of new student. After Anna picks, helper 2, Ben, has 5 new students left. Then helper 3, Kara, has 4. Then helper 4, Dan, has 3. So we multiply. 6 times 5 times 4 times 3 equals 360 ordered pairings. We write this as P of 64. The letter P stands for permutation. Step B: subtract the bad pairings. The bad ones are the pairings where Anna is paired with Xavier. Fix that pair. Now the other 3 helpers, Ben, Kara, and Dan, pair with the remaining 5 students. 5 times 4 times 3 equals 60 bad pairings. We write this as P of 53. So the final answer, 360 minus 60, equals 300 pairings. This is the same permutation formula from the foundation. P of n comma r equals n times n minus 1, all the way down for r numbers in a row. Then we subtract the bad cases. The answer is 300 pairings. Let me show you the big idea. This is the ordered pairing rule. If you assign r distinct slots to people picked from n, then use the permutation P of n comma r, multiply n times n minus 1, all the way for r numbers, to exclude one forbidden pairing. Subtract P of n minus 1 comma r minus 1. Look for the words pair r helpers with r different students. That is when this rule applies. Learn, compete, and win. Visit competitivekids.org.